Alright, now to start talking about growth. We'll have 2 to 3 videos also on growth and how animals' requirements change as we challenge them to grow and develop to be the best that they can be. One of the first things we need to do is understand how we assess growth. How is growth measured? How do we evaluate it from a food animal production as well as a performance animal production? There are several factors that are used to assess growth, all of which can affect nutrient requirements for growth. First and foremost is body weight, increasing body weight. It's one of our big measures of growth is, are they physically getting bigger? And there is a sigmoid relationship, or that S-curve kind of relationship between body weight and age. And we see a rapid increase in body weight until puberty, and then it starts to slow down until maturity, which I think we're all fairly aware of. This is an example of what that sigmoid curve kind of looks like, is that S-shaped curve. And as we take a look at it, we understand that at time point 0, weight 0, that's about conception of the animal. Then we follow that by birth, which would be age 0. We notice we have an increase in weight, of live weight, of body weight in that animal going from conception to birth. It develops into that fetus, and that once it's born, then we see a period of rapid increase until that animal hits puberty. It's increasing at an increasing rate. Then we tend to shift after puberty until maturity to increase at a decreasing rate. So when we take a look at all of these things, let me pull those back up here. So when we take a look here, what we should see is that from birth to puberty, there is a drastic increase in body weight from this side over those first several months of age. Then once we cross over from puberty, we start to see that growth rate slowing down until it hits a plateau point, and that's where we call maturity. And once that animal hits maturity, then we see a leveling off of that growth curve where that animal is considered mature, not growing in live weight or in body weight anymore. Next, we can look at an increase in size or stature, or the frame of the animal. And this is kind of getting the skeletal side of it a little bit. Size is very different from body weight. Body weight is just referring to mass, but the animal skeleton can elongate both directions, both length and height, and changes over time. We can have two different animals that are the same body weight, but they're very different frame sizes. The maximum size that an animal can be is going to be determined by genetics. Some examples of this on the beef cattle side of it. We have some of what we call our British breeds, Angus, Hereford, Shorthorn. Those breeds mature at a smaller frame size than some of what we call our continental breeds, Charolais, Maine Anjou, Limousin. Some of those types of breeds actually have a larger frame size. However, the mature cows could weigh about the same. They just have very different frame size. So genetics does determine maximum size. Nutritionally, we can't make them any bigger than their maximum size that then their genetics will allow. But what we can do nutritionally is feed them so that they do reach their maximum size. We can do that. We just can't make them bigger than that. Smaller species and breeds will mature faster than larger ones. The third way of assessing growth, so the first way was increasing body weight, the second was increasing stature or size. The third way is the composition of the gain. Organs and tissues in the animals grow at different rates. And so as that animal is maturing, their tissue composition is changing. The proportion of protein to fat to bone all changes as they grow. Bone develops earlier than muscle does, which makes sense. They need to develop that skeleton prior to being able to develop the muscle to go on the skeleton. Muscle develops earlier than fat. Fat is one of the last things to develop, which makes sense. It's a sign of maturity. And so from this picture, basically what it's showing is the relative age at which we develop some of these different things. So early on the dashed line, that's our bone, and it's developing peaks down here at an earlier age. Then if we were to take a look at the muscle side of it, that's going to be the solid line here, and we notice that peaks at a little bit later age. Then as those animals mature, what we wind up seeing is the fat, the other dashed line, matures last in terms of how much body fat they acquire based upon age. And so composition of gain is another way to assess growth. And actually some of the beef nutrient requirements and stuff use composition of gain as part of determining their nutrient requirements in some of the computer models that we talked about last time. So if we take a look at that growth curve and come back to it, early on in an animal's life, that gain that we see between birth and puberty is mostly water, protein, and some ash, or that would be the bone. Ash represents the inorganic element, and the bone is made up of mostly calcium and phosphorus and other inorganic minerals. So that gain is predominantly water, ash, and protein. Then as we take a look between puberty and maturity, we start seeing an increase in fat. That's where the gain is mostly going to be coming from fat. This is also where, like in growing animals that we're trying to finish for carcass quality, we're going to be looking in this range for them to get enough body fat on to have good marbling, to be able to offer shelf life for the meat product, and some things like that. Some other factors that can affect the composition of the animal's gain include age, the genotype, their genetic capacity for growth. Some genotypes may be leaner than others, and that's going to affect the final composition of gain. Gender definitely plays a role in composition of gain. The nutrition, absolutely. We can manipulate composition of gain through diet. And so nutrient requirements change as that composition of gain changes, and we need to be flexible and able to adapt to that. If we overfeed energy, we are going to have animals putting on more fat. And sometimes we want to do that, sometimes we don't. But we can manipulate that composition through the diets we feed our animals. The challenge is if we're overfeeding energy, feed efficiency actually goes down. That feed to gain ratio that we talked about last week in activity, right here, that feed to gain ratio, it actually increases, meaning it takes more feed to produce a pound of gain when an animal is gaining fat. So that is not efficient to be able to do that. There are times and places where we do have to have animals lay down fat, but we also as nutritionists need to know that's when the animals are going to be the least efficient, is during that time period. The fourth way to assess growth is through growth rate. We started looking into that last week when we were talking about average daily gain, and it is influenced by a combination of genetics and nutrition. And average daily gain is the most standard. We can either measure it in pounds or kilograms per day. And just looking back at that S-curve, understanding that the most rapid growth is from birth to puberty, and it starts slowing down as those animals mature. Generally, the faster the growth rate, the faster we get them to where they can deposit fat, and we'll see more fat deposited on animals with higher growth rates. That wraps up the first part on the 4 ways that we can assess growth in our animals: increasing body weight, increasing stature or frame or size, however you want to word that, changing the composition of the gain, and also looking at the rate of gain. Those are 4 ways that we assess growth in our young animals.